Here's part of a program that takes a week's worth of temperatures in degrees Celsius, calculates the average, and then determines how many of them are above average and how many are at or below average. I've already typed the part that defines 7 variables, temperature 1 through temperature 7. Now I'll add them up and calculate the average. Then, to calculate the number of items above the average, I'll set n above to 0, and then do this. If temperature 1 is greater than the average, add 1 to n above. Similarly, I can say if temperature 2 greater than average, n above is incremented, and then I'll copy and paste it, 1, 2, and make the changes for temperature 3, temperature 4, 5, 6, and 7. And now let's put in some code to display the output. The average temperature for the number of days, Celsius \n, 7 days, and our average, and the number of days above average, which is n above, and the number of days at or below the average, 7 minus the number above. Let's save this and compile it, and then let's run it. There's the average temperature, 22.8 degrees Celsius. 3 were above and 4 were below average. This program works, but what if we had a whole month's worth of temperatures? Then we'd have to have 30 repetitions of this if statement. We'd have to have 30 additions, and oh boy, it would be a tremendous mess. There must be a better way. Let's think back to algebra, where we had a variable name with a subscript to represent a group of related values. And then we could use that subscripted variable in a summation expression. Now let's think about Java. Remember that we've treated variables like named mailboxes, and each person has their own named mailbox. But if you go to an apartment building, you'll see one name, and each mailbox will have an apartment number on it. We have a group of mailboxes all associated with one name. In a similar way, in Java, individual variables are like individual mailboxes. The equivalent of the apartment building mailbox group is an array. We use the square brackets after the data type to indicate that this is an array, and we can initialize the entries by listing them in braces. Unlike apartment numbers, which begin at 1, the positions in an array start numbering at 0. And unlike algebra, where we use subscripts, we can't type subscripts in our editor, so we use square brackets to indicate the index, or the mailbox number, that we're accessing. With this knowledge, let's modify the program. First, I'm going to initialize the array with an alternate method. I'm going to declare the array as a double array named temperatures, and it will be a new double array of length 7. I don't need the word double on any of these anymore, and I'm going to change them to individually set each element of the array, starting at element 0, element 1, all the way up to 6. Now, instead of adding up all of the items in one expression, I'm going to do something that looks really weird. I'm going to set an index equal to 0, and I'm going to set my sum equal to 0. Then I'm going to set sum to sum plus temperatures at location index. That will be slot number 0, which will take 0 plus 27.2. Sum will be 27.2 when I'm done with this statement. I'll then add 1 to index to increment it. Now I'm going to do exactly the same thing again. This time index is 1, which means it'll take the 27.2 and add temperatures sub 1, which is 20, and sum will become 47.2. Then I'll do index plus plus. You're probably thinking, oh no, this is even worse than the original version. Is he actually going to copy and paste this 5 more times? No, I won't. When I see myself doing the same thing repetitively, I think, hey, can I do this with the loop? The answer is yes, I can. I'm going to say for index equals 0, index less than 7, index plus plus, sum becomes sum plus temperatures of index. And that is the same as if I had written this 7 times. In the interest of good programming style, I'm going to make this int index, and then I don't need this line anymore. And now my average is the sum divided by 7. This works great, but if I ever decide to do 14 days or 30 days of temperatures, I'd have to change this 7 to 14 or 30, and then I'd have to change this one and this one. When I initialize the array, I have to know how long it's going to be. For this one, instead of saying 7, I can say the number of items that are in the array. That's temperatures.length. If I have 14 items, this will turn out to be 14. If I have 30 items, it'll be 30. Same thing here. I'm going to divide by the number of items in the array. Now I can do a similar loop to find the number of temperatures that are above average. I can say the number above is 0, and then for int index equals 0, index less than temperatures dot length, index plus plus, if the temperatures at my current index is greater than the average, then the number above gets incremented. Let's do the output. The average temperature for days. And this time, again, instead of 7, I'm going to say temperatures.length and average. I can say number of days above average, and that's going to be n above. And the number of days at or below average is temperatures.length minus the number above. Let's compile that, and let's run it. And you'll see that it does exactly the same as the other one, except the program is a lot shorter. Again, because I'm using temperatures.length everywhere, if I have more temperatures, my program is still going to work. Let me change to the brace initialization method and set the first 7 to the way they are here and add a few more temperatures. Let's go up to 32.3. 31.8, 31.7, 30.0, 29.5, 29.5, and 29.3. I won't need these anymore, and everything else in my program is going to be exactly the same as it was before. Let's compile it, and let's run it. And this time it gives me the average temperature for 14 days and calculates the number above and below. Arrays and for loops are a marriage made in heaven for dealing with multiple related values of data.